common and natural logarithm. We want to solve for x in the given equations below. And the first example we have is 3 raised to power x is equals to 5 raised to power x minus 2. And therefore, I'll introduce the log so that I'll be able to solve these two equations. So what I do on one side of the equation, I do on the other side too. So that is the form of the equation that now I get. And the next thing I could do is to take powers down. So I'll have x log of 3 is equals to x minus 2, the log of 5. Remember, you can pick a calculator and get the value of log 3 and also log 5. That will be very easy to do so. And the next step I can do is I can separate them out. So I have x log 3 is equals to x log 5 minus 2 log 5. That is the other form that I could write it. The next final step is I could put like terms together. I could have x log of 3 minus x log of 5 is equals minus 2 log of 5. And that takes me to a very nice level whereby I can find what is common, and we have that log x is common between the log 3 and the log 5, and that gives me minus 2 log of 5. And the final step basically will be to get the value which is given by x is equals to, I'll divide through by log 3 minus log 5, so I'll get negative 2 log of 5 divide by log of 3 minus log 5. And this I can write it as negative 2 log of 5 divide by log of 3 over 5. And again, this can be expressed as 2 log of 5 divided by log of 5 over 3. I'm going to explain how that comes about. Now, if you can recall your logarithm knowledge, it says that log of a over b is equals to log of a minus log of b. I can also say this, if I introduce a negative sign, I can say negative log of a over b is the same as log of b over a, and which is log of b minus log of a. And that's why the negative sign was able to disappear when I interchanged 5 and 3. It was 3 over 5, now it is 5 over 3. You can see when I introduce the negative of a over b, it becomes positive b over a. And that was the principle that was applied there. And that gives us the solution. You could pick a calculator and you could compute those values. But that is the value of x. I can also have an equation of the form ln of x is equals to 4. So because I don't know what is the natural logarithm of x, I introduce the exponential, because the exponential and the ln cancels each other out. Exponential and the ln cancels each other. E raised to power in x is x, and x is equals e raised to power 4. So what I want you to keep in mind is that e ln of x will be x, and if it was ln of e raised to power maybe like 2, it will just be 2. ln and e normally cancels each other out. These two will always cancel each other out. So that's the knowledge that I've used to be able to solve that equation. Another example we can think about is ln. We could use the natural logarithm, or we could say a half ln of 3 minus 2x is equals to ln of x. So this one I can write as ln of 3 minus 2x raised to power a half is equals to ln of x. Remember, we've said that the exponential function, normally cancels the ln. So if I introduce e, it will cancel out the ln, and if I introduce e, so I'll be left with 3 minus 2x raised to the power half is equals to x. What's the next step? I multiply this equation 2 times, so it will be 3 minus 2x raised to the power half. 3 minus 2x raised to the power half is the same as, remember, 3 minus 2x raised to the power half is x. And since I have 2 of them on this side, it will be x times x. A half to power plus a half, using the law of indices, will give me 1. So I'll be left with 3 minus 2x is equals to x squared. I want to put these equations on the same side. So I have x squared plus 2x minus 3 is equals to 0. Based on the knowledge of solving quadratic equation, which two numbers, when you multiply, you get 2, and when you add them, when you multiply them, you get negative 3, and when you add them, you get 2. So it will be negative 1 times 3, which is negative 1 plus 3. So that is the 2. Negative 1 plus 3 is 2, and negative 1 times 3 is negative 3. So what we have is x minus 1, x plus 3 is equals to 0. So the solutions are x is equals to 1 or x is equals to negative 3. We'll be able to solve that equation that we have. The last thing I want to mention about that we are familiar with are the laws that apply. And one of them is, we know that ln of AB is the ln of A plus the ln of B. The second law that we know is ln of A minus B is still be ln of A minus B. And then the third one is ln of A divide B is ln of A minus ln of B. So it's good to keep these principles in mind, and this applies both for the ln and for the log, that is the common and the natural logarithm. So if I have ln of A raised to power 2, it is 2 ln of A, and so on. So ln is what we call the natural logarithm, and then the log is what we call the common logarithm. So that's the difference between the two, but the laws apply to both of them. So I hope you've enjoyed this video, and in case you have any suggestions, also they are most welcome, and please subscribe to my videos.